Hello Math 8 students, this is Transformation Coordinate Rules Part 2. Last time we went over translations and reflections, and today we're going to go over rotations. But to get started, we are going to look at this warm-up. We have triangle ABC, and we need to translate it following this coordinate rule. You need to plot those 3 new points. If you want to sketch this on your own paper, that's great. If you just want to write down the coordinates of the new points, that's also great. Pause the video to get this done. All right, so taking a look at this, when I see x minus 5 right here, that tells me that I am going to be moving everything to the left 5 units. 1, 2, 3, 4, 5. And when I see this plus 2, that tells me that I'm going to be moving everything up 2. I know I'm going up 2 because I'm changing the y coordinate, and the y coordinate tells me what goes up and down. And this was left because I was changing the x coordinate, which goes to the left and the right. So that new position for b prime there, that is the coordinates 1, 2, 3 to the left, 1, 2, 3 up. So b prime is negative 3, comma 3. A. Again, we go 5 to the left, so 1, 2, 3, 4, 5, and 2 up. So a prime is now in this position with coordinates 1, comma 1, 2, 3, 4. And C follows that same pattern. We go to the left 5, 1, 2, 3, 4, 5, and we go up 2, making this the new position of point C or C prime. And the coordinates there are over 0, down 1, 0, comma, negative 1. When you're doing this on paper, you probably should connect those and form your new triangle. On the calculator, obviously you weren't able to do that, but you were able to get those points in the correct position. Those of you who were doing it on the calculator, I made it possible so that when you placed your points down, you could see those coordinates. And so if you couldn't get those coordinates to match, or I guess a way that you could check your answer is to go 2 minus 5, is it really negative 3? And 1 plus 2, is it really 3? And follow that coordinate pattern, not just moving it and shifting it that way. So again, we have our translations from yesterday. I did assign homework. We have our reflections from yesterday, and again, I did assign homework. I told you to break it up, but I'm not actually going to be checking that homework today. I'm going to wait until the whole entire packet is completed, and I'm going to be checking the whole entire packet tomorrow. So whatever we don't complete in class is homework. Let's move on to our rotations. Rotations are a little bit trickier. But as long as you go nice and slow and follow the steps that we built yesterday, you will be successful with them. So here we have a point. I'm just going to call it S. You can call it whatever you want to call it. I'm going to call it S. To get started, I always like writing down those coordinates. So S has the coordinates of 5, comma 1. And S is going to be transformed to S prime with new coordinates that I don't know yet, but I'm just setting this all up so I can just fill those in. Okay. This is how I like showing my work. I write down the coordinate, show what it's going to go to, but then I always write the rule right up above it so that I can really make those connections. And so rewriting that rule right here, xy goes to, again, I would say this, opposite x and opposite y. It's not negative x and negative y, it's whatever x is, it goes to its opposite. And whatever y is, it goes to its opposite. So xy goes to opposite x, opposite y. And so x goes to opposite x. So here 5 is going to change to be the opposite of 5, which is negative 5. And y goes to opposite y. So 1 is going to go to negative 1. The opposite of 1 is negative 1. Now we can plot that new point, negative 5, comma, negative 1, and we know that that is our S prime. That was my next question. Great observation. My question is, how much did it rotate? And it might not look like a rotation when all we see is a single point. But it does tell us up here that it was a rotation. So I know it was a rotation. Quiet think time. How much did it rotate? Garrett already gave away the answer. He already saw it. We're not discussing. We're not discussing. Quiet think time first. And now discuss. And now share with me. Share with the class. It was a rotation. How much, Nadia? 180 degrees. And that's not fully 100% correct because all rotations need a center. So what is a center that was rotated around? The origin. Yep. All of these are going to be nice and easy. They are all going around the origin. But I want us to be really clear on all of our transformations that we're being really precise. Rotation 180 degrees around the origin. Notice I didn't say the direction. 180 degrees is the only one that I don't really care about the origin or the direction because it doesn't matter if it's clockwise or counterclockwise, the result is the same. Now for anybody who might be struggling to visualize this rotation, what I like to do whenever it's just a single point is I drop a line that goes from the point down to the axis. And then I use the axis to be like the base of a triangle. And then that triangle goes from the origin to that point. And so then I can see, let's see, when this line here, this x-axis is rotated 180 degrees, it's still going to be the x-axis. And we can kind of form that triangle, and maybe that helps you visualize it a little bit more, maybe not. It's just something that I like to do whenever I'm rotating a single point. Okay, now it gets harder. That one wasn't too bad, was it? No, but the next one gets to be a little bit more tricky, which is why all of the strategies that we have utilized in the past are definitely going to be helpful today. So let's label this point. I'm going to call this one P. P has the coordinates. What? Let's see how good you are at even just writing coordinates. Zeta. You got it, -4, 5. And -4, 5 is going to go to a new point, which we're going to call P prime. So I'm just getting it all set up so we can just plug in those new coordinates. And just like I said before, I always like to write that rule up above it. So xy goes to, nope, just y comma opposite x. So what I need you to do now is talk to your group. What is happening? We know it's a rotation. I'm not looking for how much it's rotating. Just, do you see what's happening with those x's and y's? Talk to each other and try and explain it to each other. Share your ideas. What is happening with those x's and y's? Thank you, Garrett, for noticing that mistake. Okay, are you ready to share with me? What's happening here? Describe in words what you're seeing. Xander? This is mostly true. What Xander said is the y is staying the same and the x is changing to its opposite, but that's not the only change, is it? Look really close. Landis? Nope. Xander, what's the other thing that's happening? They switched y and x. Look at x is supposed to be in the first place, right? And what do we see here? It's not. And y is supposed to be in the second place, but it's in the first place. So we are making two changes. Yes, that x goes to its opposite because that's what it says here, but that's not the only change. We're also, do you see it? We're flip-flopping them. It does. So watch. xy goes to y opposite x. There's two changes that are happening here. We have to switch our x's and our y's. But then we also have to change the x to its opposite. That's a lot to do all in one. So let's just do one at a time. Again, let me just point this out. I'll highlight. X is now here in this position. And y is now here in this position. So do you see that? That's what we're going to be doing here too. So y is going to be in that first place. The x is going to switch and be in the second place. Let's make that switch. -4, 5 is now going to switch to being 5, -4. Make sense? Like I said, one step at a time. One step at a time. So all I'm focused on right now is just flip-flopping those. But is that the only change that I need to be doing right now? No, because we also see that the x has to go to its opposite. So it was -4, and now I need to change it to a +4. Yep. Like I said, we're just doing it one step at a time, though. Make that flip-flop, and then worry about changing things to the opposite if needed. Let's plot this new coordinate. P prime is now at 5, 4. Labeling it P prime. Quiet think time. No talking right now. Quiet think time. How much did it change? How much was it rotating? Quiet think time. Quiet think time. And now discuss. How much did it change? Okay. How much did it change? We know it's a rotation for sure because it says rotation. And I already warned you that all of these were going to be rotated around the origin. So rotation, something around the origin. What goes in the middle? Audrey, how much did it rotate? 90 degrees clockwise. Yep, we need the direction on this one. So rotation, 90 degrees clockwise. It's just a really big degree sign. We do need to know if it's clockwise or not clockwise. So again, something that helps me, maybe it helps you, maybe not. I like to draw that line that goes down to the axis, draw on the actual axis and kind of form a triangle. Helps me visualize it a little bit better so that now I know that this line that's going straight up and down is now going to be going straight horizontal, straight across. And the axis, the x-axis was rotated 90 degrees to be the y-axis, so we can kind of observe that rotation a little bit better. Okay. And I'm hearing that some students said it was 180. Watch, and you're going to see something really interesting. Okay? It changed just one quadrant. This was the negative positive quadrant. This is positive positive. But you see how it's kind of broken into 4 sections? We went from one to the very next one. That tells you it was 90 degrees. Here we went from here to, skip this one, made it to this one. So that tells you that it would have been 90 and now 180 degrees. Yep, big brain. Okay. Are you ready for this one? Where now it's a triangle. Okay. We did a triangle. Well, I didn't make you do it for all the coordinates, though, just for the one. But it's the same idea, right? Just pay attention to the coordinate rule. Now we've got 3 points. I'm going to call this triangle CAT. Okay, so I have C with coordinates. You guys should be writing these down. C with coordinates -3, -4, and it's going to go to C prime. I don't know what those coordinates are. I'm just setting it up so I can just fill it in. A has coordinates a -3, -1. And it's going to go to A prime with its new coordinates. And T, that's fine. T has coordinates 0, -1, and it's going to go to T prime, which is its new coordinates that I'm going to be finding. And like I said, I like to rewrite that rule right up above it. So it is for sure a rotation, and XY goes to, careful, opposite Y, X. Don't forget about that guy right there. What's happening? What's happening? What's happening? Do you see the coordinates and the changes that are happening there? Talk with your groups. Okay, what's happening with these coordinates? What is the change that you're seeing? Cambry. Yes, we are seeing that Y is going to its opposite. Is that the only change, though? What else, Cambry? Yeah, we switched them again, right? X, which should be at the beginning, has now moved to the second place. And the Y that should be at the end has moved to the first place. So it's similar to our last one, just a little bit different, right? But let's follow that then. X is now going to go to the Y. I'm color coding just to kind of make it a little bit more obvious. And that's all I'm going to focus on right now is just the x going to the y going to the x. Which means that negative 3 comes down here to the end. And the negative 4 goes to that beginning. But is that the only thing? Cambry also said, hey, that y value, which is now in the x position, it needs to go to its opposite, which means that negative 4 going to its opposite is going to be positive 4. We'll get there. Negative 3 comma negative 1. So that means the negative 3 goes back here. The negative 1 goes right here. But that's not all. We also have to change that negative 1 to its opposite, which means it's going to be positive 1. Keep making those changes. 0 comma negative 1 is going to be negative 1 comma 0, but then, not going to forget, we have to change it to its opposite, which means it's going to be a positive 1. Let's plot those new points. C prime is 4 comma negative 3. 4 comma negative 3, labeling that C prime. A prime is 1 comma negative 3. That's A prime. T prime is 1 comma 0. That's T prime. Drawing that triangle. Do you see it? How much did it rotate? Because we know for sure it's a rotation because it told us in the beginning it's a rotation. How much did it rotate, Anthony? Which direction? It's never finished until you tell me the direction. Nadia? Counterclockwise. Good. "90 degrees counterclockwise." We're not done though. Around the origin. What if you didn't see it as counterclockwise? What if you just really like the way that the clock goes? Well, that would be 90 degrees and 180 degrees and 270 degrees clockwise. You could say 270 clockwise. That's fine. Okay, guess what? Number 16. Homework. Guess what else is homework? 17 and 18. And now, let's turn to the next page, because now we're doing something similar but different. We're working backwards. Yes, Camden, you have a question? Okay, let's go over this. Eyes on the screen. In the past, I've said write a rule. Whoa. I've said write a rule to describe each transformation, but I let you write it in words, like a verbal description. Now I need an actual rule using the coordinate notation. So to get started on each of these, it helps if we figure out which one is the starting place and which one is the ending place. And this is triangle SQR. This is triangle S prime, Q prime, and R prime. So this one is the original. This one is the new one. See that? Okay, so how is it changing? How is this changing? Let's see. R is going over to the right. 1, 2, 3, 4, 5, 6. So let's write that down. We went to the right 6. And I already jumped ahead. Yes, this is a translation. So it's a translation right 6 units. And down 1, 2, 3, 4, 5 units. 5 units down. So what is the rule? This is how we've done it in the past, but now we need to use that coordinate notation, which means we would need to write, this is a translation, where xy goes to, how is the x value changing? Well, the x value is moving to the right by 6 units. So that means the x value is getting bigger by 6. X plus 6. But we're going to be subtracting in the y value. You got it. The y is going down 5 units, so y minus 5. Okay, so was that too bad? Yeah, you're doing it backwards. Where now you have the transformation given to you, so you have to write the rule. Exactly, we're doing it backwards. So, can I leave you with 20 for homework? And 21 and 22? Because 23 and 24 are the hard ones, and I'd really rather do the hard ones together. Is that fair? Okay, let's do these hard ones together. First, look at number 23. Is this one a translation? No, it's a reflection. Reflection over. Good. Reflection over the x-axis. So maybe you already know how to write a rule for this. Maybe not. Here's what I suggest. Pick a point. Just do it with one point. I like the point C. So again, here's C prime, so this is the original. And C has the coordinates of, let's see, 3, 1. What did C go to? What are the coordinates of C prime? Oh, my mistake, I'm sorry. C is 3, negative 1. And what are the coordinates of C prime? 3, 1. How did those coordinates change? Y flipped? What do you mean Y flipped? It went to its opposite. Did the X change? No, so X is going to change to X itself, no change. But Y is going to go to its opposite. Again, was that hard? No. This is not fully complete. Let's also fix it and say this is a reflection. Just put that at the beginning. Not too bad overall, right? And now this one's the hardest one of all. What's happening? Here is triangle WXY. Here is triangle W prime X prime Y prime. Rotation 180 degrees. Good. Rotation 180 degrees around the origin. And again, it helps to pick a point. Here's what I encourage you to do though. Don't pick something that's on an axis, because that gets to be confusing. So I'm going to pick point W right here. W, we're writing the coordinates. That's 1, 2, 3 to the left. So negative 3, 1, 2, 3, 4, negative 4. And it goes to, I'm going to write the coordinates of W prime as well. W prime is 1, 2, 3, 4. Can you see how it changed? Now we already know it's a rotation because we already identified that, so I'm going to start by writing that out like I did here. Reflection, we're going to write rotation. Where XY goes to, talk to each other first. How are the X and Y's changing? Talk to each other. Okay, are you ready to share with me? XY goes to Callista. Opposite X, opposite Y. Perfect. So again, the rest of it is homework. That's it for today. We'll see you next time.